angles have equal measure, then the angles are congruent. Okay? Is that a true statement? If two angles have the same measure, are they congruent? Sure, that's true. So it has the truth value of this statement is true. It also asks us to write the converse of that statement. And the converse of that statement, it also asks us to write the converse. We learned that last class, converse, inverse, and contrapositive. Which one is the converse? Who remembers?
The one
when you flip them, yeah, exactly. When the conversation, you switch things around, right? So exactly. So it's Q then P. Okay, you're switching the hypothesis and conclusion. So hopefully that's what you wrote. Let's figure out which one of these it happens to be. It would be if the angles are congruent, then the angles have equal measure. So wouldn't you agree that this is going to be the converse? Hopefully that's what you wrote. Is that what you wrote? Is that a true statement? Yeah, it's true as well. So when the converse and the original statement are both true, then we know we can write it as a biconditional. So how do I do that? This was your question, Josh, at the beginning of class, right? So the if and only if must go in the middle, and we're going to put the one of the statements in the first part and one of the statements in the second part. It honestly doesn't matter which way we go. But we'll go ahead and start. So if two angles have equal measure, I shouldn't say if, should I? Because there already is if in the if and only if. Two angles have equal measure if and only, I'll go ahead and rewrite that right here. So, two angles have equal measure if and only if, what? They are congruent. It's that easy. Taking a statement, looking at its converse, looking at their truth values, and then writing them as a biconditional. It's that simple. Okay. Now take a break and let's look at your homework for a second. Your homework, I did grade the Venn diagram question, which looked at, I think it was 9A and B. So it's on the staple sheet. So if you'll go ahead and get that out and let's look at that one. Please do. I did find it this one. Yes, we did. Okay. And let me tell you about why so many of us got it incorrect. Can we recreate the Venn diagram for us? Let's look at the numbers. It was one of those works after school, works on the weekends or something like that, is that right? So after school and weekends, so after school and weekends, and then I believe the numbers were 5, 3, and 17. Okay. So for 9A, it said how many people worked after school and on the weekends. I'm just using my symbol here, right? And? So what is that going to be? What are we going to look for the and part? The middle, right. So we're looking at where the two things overlap. I agree. And in that case, it's going to be, or in this case, it's going to be 3. Okay? So 3 people work after school and on the weekends. That's why that answer was a 3. Now, if you look at 9B, it said how many people work after school or on the weekends, right? And most of you wrote 5 plus 17, which is part of the answer, but not all of it. The actual or part is everything on the inside. You add them all together. Okay? So it's going to be 25. Okay? Oops. So that's just one little thing there. Okay? If it said only after school, what would the answer be? 5. Only on the weekends would be 17. Okay? So just make sure that you realize that the or is when you add everything. Okay? It's one or it could be the other. I don't know. It could be both. Right? All right. So let's go ahead. Are there any other questions on the homework? I don't really have an answer key posted for you to check. But is there anything that you worked on or did that you weren't sure how to do? You want to look at yours I know Josh had a question about live conditionals. Can we answer that for you now? Good. Anything else that we came across you weren't sure of? You know inverse, converse, contrapositive? You know, draw the Venn diagrams? Yeah? Okay. Sure, no questions? Feel good? Okay then. Okay. Contrapositive. We're actually going to do the law of contrapositive today. So let's just refresh our memory about what the contrapositive is. So this is something good for Eric to know since he wasn't here last class. If we have a statement, okay, and this is called a conditional statement, we have three things that we can write. We can write the converse, which you guys just told me was when you switch the hypothesis and conclusion. We have the inverse, and then we have the contrapositive. Okay? Jason wants to know what the contrapositive is. In symbolic form, what is it? Okay, squiggle, that's fine. Yes, not is fine. Not what? Not Q. Sometimes we call it implies that, rather than, so you can say like not Q implies that, or you can say if that, that's fine. And then that would be not Q. Very good. Okay, good. So you're basically switching the two, hypothesis and conclusion, and negating them. Good. Just out of curiosity, the inverse is going to be what? Not P, implies that, not P. Yeah. Oops, yeah, it's not. Pretty easy. And honestly, there's nothing more than just memorizing that stuff. Which things have the same truth value all the time? Contrapositive and what? The original statement. Okay? So these are the two things that have the same truth value. Okay? As a matter of fact, the converse and inverse also do. Okay? But the contrapositive and the original have the same truth value. Okay? Always. And you're going to deal with that on your project. Sure. I didn't catch next Wednesday. Okay? So you have some time. And I'm not going to give you any homework on Friday other than to work on your project. Okay? So that's going to be your homework on Friday to finish it. And you have to teach your work day, so you should have plenty of time to get that done. Okay? All right, so here we go. I need for us to go ahead and take out your foldable. Hopefully you taped your not foldable, your flip chart, whatever you want to call it. Hopefully you taped your 3 note cards. If you haven't done so, I need you to do that. We have several tape dispensers over here. Feel free to grab one, use one. Any table need one? Okay. All right, we're just going to pass. There's one on my desk. All right, here you go. You only need 3, so just tape the 3 for me. You pause this while we're taping it. So once you have these taped down, I want you to, we're going to write that there are 3 laws of logic that we're going to study in this class. There's more, but only 3 that we're going to talk about. And the first one is here, law of detachment. And as you can see from my example, I wrote law of detachment fairly large here at the bottom. I even highlighted mine so you can see what it was. Feel free to copy that if you want, that's fine. But make it, distinguish it from the rest of the card. Okay, so law of detachment is going to be our first one. And then we're going to kind of add the others along with it as we go, okay? The law of detachment, this law here, is going to be our first example. What I'm looking for you to do is to draw on the front of the card the circle. It kind of looks like a Venn diagram. I want you to draw the circles on the front, and I want you to put the symbolic form on the front. On the back, you're going to write 3 statements, okay? So once you've got it taped, go ahead and draw. I'll highlight what goes on the front. So this goes on the front. Okay. And then this will go on the back. So front, back. So I'll take a second for you guys to copy that down, okay? And you get asked if the dot was important. The dot is extremely important. So please put with the dot where you see it. Okay, excellent. All three of these laws of logic have three statements. Yes. Oh, one is sorry. Eight. There we go. Anybody else want to get taken? All right, you can give it to Brittany. So all three of these laws of logic have three statements. The first two statements are kind of like the given information. The third statement is always a conclusion. What conclusion can we draw from the two previous statements? Okay, so I'm going to say that one more time. The third statement is always going to be the conclusion statement. Sometimes we draw a line, and we just say that this is our conclusion. Okay? So, if you look at your symbolic form, the PQ thing, what kind of a statement do you think we're always going to have as the first one? An if-then statement or a conditional statement, either way you want to say it. What kind of a statement is number 2 going to be? Is it going to also be a conditional statement? Look at the example we have. It's definitely not. So if we're going to use the law of detachment, we're not going to have the second statement be an if-then statement. What it will be is an example of P. So what I mean is you look at the symbolic form here, okay? We have an example. P, the second statement has to relate to what P is, what the hypothesis is of the first one. So let's look at the Venn diagram, see if this makes sense. Let's fill in on the Venn diagram the information here. And you can draw the Venn diagram on the back if you want that matches it. This on the front is just kind of a template, okay? So don't fill this in on the front, but you can fill it in on the back if you choose. If you go to SJHS, where does SJHS go in the Venn diagram? Outside all the circles, inside the large circle, inside the small circle, where does it go? If we're doing an if-then statement, where does the hypothesis always go? In the smallest circle. Good. So we're going to say SJHS here. So if you go to SJHS, then, so where does get a high school diploma go? In the bigger circle, right. So we're going to say high school diploma. Good. All right, good so far. So I've drawn a Venn diagram that represents the first statement. If you go to SJHS, then you'll get a high school diploma. Now I'm going to go ahead and look at the second statement. Carmen goes to SJHS. Carmen is the dot. Okay? So this is Carmen right here. Notice where Carmen is. Carmen is on the inside of SJHS, isn't she? Because that's what I said. Carmen goes to SJHS. She's on the inside of that circle. There she is, right here. Well, what other circle is Carmen also inside?
The bigger one.
The bigger one, which is the conclusion, which is why your conclusion statement is that same example, just based on Q. So we're going to say Carmen must get a high school diploma. Carmen will get a high school diploma. So the first, in the law of detachment, the first statement is the conditional one. It's your if-then statement. The second statement is an example based on the hypothesis. And your conclusion is that same example based on the conclusion of the original statement. Pretty straightforward? How many conditional statements do we have? A total of how many? 1. That's important because it doesn't always happen. Okay? All right, let's go to the second law. The second law is the law of... Good question? I'm sorry, Margaret. Go ahead.
Your statement is not really true. Because you can go to some other...
We're not talking about truth value. Okay? We're going to assume, and I agree, some people might not get a diploma. Or you might get an advanced diploma, or some other kinds of things. I agree. We're going to assume that the two given things are true. We're going to assume they are, and then we'll have to base our conclusion on that. Okay? Good thought, though, because you're thinking of the counterexample. I know where you're going with that. All right, let's look at the next law. Okay, so on your second index card in your flip chart, You want to write relatively large here. You can highlight it if you want. It's called the law of syllogism. It's kind of a funky word, okay? Syllogism. I want you on the front to draw the Venn diagram template and the symbolic form. And then on the back is where I want you to write your 3 sentences. Okay? All right, so we have, how many conditional statements are we given here? 2. Very different from the law of detachment, right? The law of detachment, we only had 1. So this is a clue that it's the law of syllogism, okay? When you're given 2 conditional statements, and it's very important the way that they're ordered. Look at your symbolic form, okay? We have if P, then Q, then if Q, then R, and then our final statement is P, then R. It's kind of like the transitive property, if you remember that from when we did proofs, a little bit like that, okay? So let's fill in the Venn diagram, and again, I want you to leave the template on the front. You can fill it in on the back if you want. Let's fill in the Venn diagram with what we have so far. So with the first statement, if it is July, then you are on summer vacation. Where does the word July go in the Venn diagram? Very, very center, the smallest circle. I agree. If it is July, and then where does summer vacation go? In the middle, right? So then we're on summer vacation. Oh, summer vacation, I missed you. Vacay. Okay. So let's figure out the second sentence. So if you were on summer vacay, is that okay where it is? Because it's on the inside of another circle, right? So if you're on summer vacation, then what? You're having some fun, right? So that's how the progression of the Venn diagram is going to look. Now let's look at the conclusion here. Notice that if you're looking at your symbolic form, it's going to start with the hypothesis of the first statement. So if it is July, and then we're kind of think about crossing out the middle part. Summer vacation, and then how's it going to end? Then you're having fun. So if it's July, then you're having fun. That's going to be your conclusion sentence. Remember, the third statement is your conclusion. Okay? And it's our valid conclusion. So if it is July, then you are having fun. Question?
Like done like the transitive property.
That's what I just said. Yep. Very similar. Yeah. Just like that. Good. Now, sometimes they try to trick you, and they don't put them in this order. And we're going to look at a couple of examples like that in a few minutes. But really think about the symbolic form is there to almost kind of help you. And the Venn diagram is kind of there to organize your thoughts as well. Okay? So sometimes I will ask you to justify. I'll say, which law of logic are you using? Then I'll say, write a conclusion if possible, a valid conclusion. And then I'll say, justify. When I say the word justify, I mean draw the Venn diagram with the words in it or use your symbolic form. Okay? Either one is okay. But you do have one more law of logic, so let's look at this guy. Okay, so your last index card should have the law of contrapositive on it. A law of contrapositive. And again, on the front of your note card, just go ahead and put the template there. And then your symbolic form goes on the front. And then on the back is where we'll write our 3 sentences. Okay? We already know what the word contrapositive means, don't we? Jason, that's beginning class, right? So we know what it is. We know that the contrapositive of a conditional statement is when you flip them and negate them, right? That is what the contrapositive statement would be. The law of contrapositive kind of uses that same idea. The first statement is going to be a what kind of statement? A conditional. And then, is that the only conditional statement that you see? It is. The following 2 are just regular examples, kind of like the law of detachment. what is the difference? Look at the Venn diagram. Where does your example go? Outside the box, right? All the way on the outside. So, here's our first conditional, okay? If it is a bicycle, then it has 2 tires. Do all bicycles have 2 tires?
No.
Yes, they do. That would be a unicycle if it only has 1. So all bicycles, bi meaning 2, do have 2 tires, right? So this is a true statement. Good. Oh, okay. That could be But I just said if it's a bicycle, that it has two tires, right? I didn't go the other way around. I wasn't looking at that. You're talking about the converse when you switch them around like that. Good thought, though. So you couldn't write it as a biconditional, could you, Jason? Because the converse is not true, right? If it has 2 tires, it's a bike. You would. Okay.
Wait, if one is true, then biconditional means another two.
All right. So if it's a bicycle, then it has 2 tires. My vehicle does not have 2 tires. So here's my little vehicle stuck out here, right? My vehicle. So it's all the way on the outside. Why does the dot have to be all the way on the outside? Why can't it be just outside a bike? Because then it would be inside something. It could have 2 tires. So it has to be all the way on the outside. If my vehicle does not have 2 tires, what also does it not have? Or what also can it not be? A bike. So my vehicle is not a bike. True? Not a bike. Okay. So I would like you to go ahead and take a look at, so we're done with this flip chart for logic. Okay, we've written a lot of logic on there. We have talked about Venn diagrams. We've done the symbolic stuff, inverse, converse, contrapositive. We did it all. Okay. What I'd like us to look at now is the 2-4, and I want us to kind of decide, if you would, on the back. Okay. I want you, we'll start with number 1. I'd like for you to just try problems 1 and 7. Okay, so right now, just do number 1 and number 7. That's it. Okay, just try those 2. Okay, let's look at these. I gotta give it another minute. Okay. All right, guys, let's go ahead and look at these. So, in problem number 1, we were told it was the law of detachment. But how do I really know that it is the law of detachment? Well, we can probably draw the Venn diagram and just verify. So, we have an if-then statement. If a triangle is a right triangle, then it has one 90-degree angle. Right? Triangle ABC is our example, so it's a dot, and it's a right triangle. So triangle ABC goes here, on the inside of the right triangle circle. Is that a valid picture for the law of detachment? Yeah, sure. We can also say that we have if P then Q, we have an example of P, so what's our conclusion going to be? Triangle ABC has what? Has a 90-degree angle. Perfect. Let's hop down to number 7. Okay? To take calculus, you must first take algebra 2. Okay? So to take calculus, you must take algebra 2. To take algebra 2, then you must take algebra 1. Is this a valid law of, what's the word? Syllogism, right? So what is the conclusion here, Jason? Help me out. To take what? Exactly. You must first take algebra 1. Excellent. While I'm finishing writing this, can you draw the Venn diagram that goes to number 4? So how goes with number 4. I'll write the statement up here. What would the Venn diagram look like in number 4? We have an if-then statement, so I know I at least have this portion of the Venn diagram, correct? So we have if cats prowl, then the mice will scatter. So I have my if-then statement. Where does my example go? Because second 2 is mice are scattering. So we can say, I don't know, where are the mice on Cinderella? Jack? Jack? No. Jack? I don't remember. But anyway, so let's say that this particular mouse we saw scattering. We saw a mouse scattering. Where does that dot go? Does it go on the inside of the cats? It's not talking about cats, is it? What's it talking about? So it can be out here, it could be inside, but not necessarily for certain. So it's most likely here, right? So we can say that the mice are scattering. Can we make any conclusion based on that at all? We can't say anything, actually. We can't say anything about cats, because this mice are scattering, maybe they're scattering for a different reason. Maybe they're scattering because water is flooding into the house, or flooding into something. That's another reason why mice would scatter. Maybe the dog's chasing them. Not that they do with the cat. There could be other reasons. There's no valid conclusion here. So if you would write that for me, please. No valid conclusion. It's important to know what that's going to look like. That happens sometimes. Okay, sometimes you just can't draw a conclusion. I think the Venn diagram is the easiest way to see that. The law of attachment, the dot has to go on the inside of the cats. Okay, that's where you have to be. All right, if you would, one last one before we do our notebook check and talk about what's happening on Friday. I'd like for you to turn over on the back, and I want you to look at problem number number 17. Actually, I'm changing it. Can you do 16? I'm sorry. 16. Look at 16 for me. Try to draw a Venn diagram for that one as well. So this is an example where you might use both the law of syllogism and detachment. You should notice here we haven't run across any law of contrapositives, right? So we always have to be on the lookout for that one. This particular sheet only covers syllogism and detachment, but you should always be on the lookout for the contrapositive. So let's draw here. If it is raining, then the temperature is greater than 32 degrees Fahrenheit. If the temperature is greater than 32 degrees Fahrenheit, then it is not freezing outside. Which law is that so far? That's the syllogism part. The last sentence begins the law of detachment, and it says it's not raining. It could say something like, Tuesday it rained. It could say, it rained on Thursday, whatever. Let's say today, what is today? Today is, what going to be, Wednesday? Okay, right? So Wednesday, it is raining. It's not raining outside, is it? I don't have a window. So it is raining. So it is raining, meaning yes, it's raining. There's where our dot goes. So what conclusion can we draw? You can actually draw two. We can draw that it must be greater than 32 degrees outside. And what else can we say? That it's not freezing. And so both of those would be correct things. Oops. We should really just say it is not freezing. All the way to the outside. Well, you could just put the word rain again. idea like Tuesday it rained or something like that, you could write the word Tuesday. Okay? Feel okay about the laws of logic? There's 3 of them. It's a matter of knowing which one to use and when. That's really all there is. Next class, we're actually done with logic. There's nothing else to do. We've done it all. Okay, except for truth tables, which we'll do at the end of the quarter, or end of the after SOLs. We have decided as a team that we're not going to give you a logic test because it's a short little unit, right? It was only a couple days. So what we're going to do is we're going to give you a quarter test. It's not something I'm thrilled about. I think we give you enough tests, but we don't give midterms anymore. I don't know if you guys are young, but you might not know, but we used to give midterm exams, semester exams, and it counted as a major part of your first semester grade. But the county's gone away with that, so instead of a semester exam, we're giving quarter tests, okay? And it's kind of a summative of what we've done all quarter. Your quarter test next class will cover is 30 questions. Okay, so if you wanted to write this down, you can. Quarter test is 30 questions. Okay, all multiple choice. Okay, that is by design, because honestly, if I'm giving it to you right at the end of the quarter, I gotta grade it. Okay, it is going to count as much as a traditional test. So but you're only going to have 3 sections. Okay. The first section is going to be on coordinate geometry and constructions. There will be 8 questions on coordinate geometry, and there will be 2 questions on constructions. Okay. A multiple choice question on constructions can really only be written 2 ways. One would be, what's the next step of this construction? Or what's the name of this construction? And it just kind of shows you the steps. That's one way it could be written. Or I could give you something like this. Hang on a second. Yeah, sorry. I give you, like, let's say an angle. And I give you A, B, C, D. And I say, which of those dots is on the angle bisector? How would I do that question? It is still multiple choice, right? But how would I have to solve it? Or what would I have to do to be able to answer it? I'd actually have to do the construction, wouldn't I? Okay? So that's a possibility too. So I will have compasses here for you if you want. Okay? But you have 2 construction questions that are multiple choice. And then your next section is on parallel lines. Now, I still have your parallel line test because we're still waiting on a student to finish taking it. He's been sick and has to, anyway, long story short, he should be taking it on Monday. Oh, parallel lines, sorry about that. So to study for that, you had your quiz back, I do believe, though, correct? So I think I gave you your graded quiz back on parallel lines. You also should I would look over your quiz, correct it, make sure you understand it. I would look over the foldable, or the flip chart that we did at the beginning of parallel lines, any of your notes. But I think the test was pretty easy. Y'all did really, really well on it, so that should help. And then the last section is going to be on logic. And you are going to have 10 questions on parallel lines and 10 questions on logic. Okay? So that's how it's going to kind of be divided.
We only have 2 questions on construction.
Uh-huh. Are they your favorite thing? We're doing a lot more construction. We're going to do them all year long. They don't go away. We're going to construct a hexagon. We're going to construct an equilateral triangle. We're going to be constructing a tangent to a circle. All kinds of things we're going to be constructing. Okay? So the compasses are with us all year. Sorry, I know they're your favorite. They're here to stay. All right, any questions on what you guys can expect next time? Your only homework really is going to be to study for the quarter test, okay? And to continue to work on your MYP project, because you guys know you have that due next Wednesday. I do want you to go ahead. We're going to take the last few minutes to do our notebook check today. So you can leave your binder out. That's totally fine with me. You should have a folder at your table. Just put it up. Yes. No. Only because I want you